Welcome back to the SPI series. In the last chapter, we discussed about the SPI protocol and how an SPI is hooked up from a master to a slave. In this chapter, we will discuss in detail on some of the interview topics on SPI. Let us begin. Let us start with some of the common questions like what does an SPI stand for? It's a serial peripheral interface and SPI is developed by Motorola. So is SPI a serial or a parallel communication? SPI is a serial communication. What does it mean? It means they send data serially on a single line or a same line. How many wires are required for an SPI communication? So the SPI interface is 4 wire based. So this is a general statement. But if you want to connect more slaves to the master, you need to have more slave select lines. So what are the common lines? You have the MOSI or SDO, master out slave in, or MISO or SDI, that is the slave data in, and your SCL, which is the clock line, and you have the slave select. So these are the 4 wires that are needed for an SPI communication. So the next question is it possible to have multiple masters in an SPI architecture? No. SPI has a disadvantage in this regard that it can have only a single master. And the next question is it possible to have multiple slaves in SPI? Yes, SPI definitely supports multiple slaves as we saw in the previous chapter. The next question is what are the advantages of an SPI communication protocol? The first thing is there are no start and stop bits. So the data can be streamed continuously without interruption. You need start and stop bits when it's an asynchronous protocol like a UART, where you need to, because there is no knowledge of a clock between the master and the slave, you need to have a start and stop bit, which is not the case for an SPI protocol. It supports full duplex, that is, at the same time the master and slave are transmitting data to each other. There is no need for precision oscillators in the slave device as it uses master's clock. There is no complicated slave addressing system like the I2C. It has higher data transfer rate than I2C, almost twice as fast. There are separate MISO and MOSI lines, so data can be sent and received at the same time. And the software implementation for an SPI is quite simple. These are the advantages of an SPI protocol. Now the question is, what are the disadvantages of an SPI communication protocol? Since there is more than one slave in the communication, the wiring will be complex. So if you are looking at a PCB level, if there are more slaves, if there are n number of slaves, you need to have n number of slave select signals. And this becomes complex when you are routing your PCB. It uses 4 wires, while some of the other protocols use 2 wires. No acknowledgement that the data has been received successful, and this completely depends on how the frame format is defined for an SPI. There is no form of error checking like a parity bit in UART. And also lastly, it only allows a single master. So these are some of the disadvantages of an SPI communication. Coming to some of the other common questions. Does SPI slave acknowledge the receipt of data? No. SPI doesn't have an inherent acknowledgement like we have in the I2C. Does SPI have a higher throughput than I2C? Yes. SPI is faster than I2C. Does SPI support duplex communication? Yes, SPI does support duplex communication. So this brings us to the end of a small series on SPI. Please do check out similar series on I2C and other communication protocols in my channel. Thank you.